Hello everyone, I hope you are doing great. This is Algo Conqueror, back with another playlist on bit manipulation in InterviewBit. This is the first problem. We are given an integer and we have to return the number of ones in its binary representation. For example, let's take 10. Its binary representation is 1010 and there are 2 ones in its binary representation. So we have to return this 2. So how do you check a bit is set or not? I am giving you a binary representation like this. And how do you say this particular bit is set or not? Can I say that if I take a number like this and do an AND operation, what will I get? I'll get, if this particular bit is set, I'll get 1 at that position, and everywhere else I'll get zeros. Alright, now let's take another example where I'm taking 0 in that particular position and I'm trying to do an AND operation with this number. If you do an AND operation, what will this give you? All this becomes zeros naturally, but this one also becomes 0 because here there is a 0. So if you'd like to know whether a particular bit is set or not, you have to do an AND operation with 1 in that particular position. This is a 2 power x. In this case, this is 2 power 3. You basically have to left shift x times, left shift 1 x times in order to get this number. Alright. So if the result is 0, then it indicates that that particular bit is 0. If the result is not 0, it indicates that that particular bit is not 0. And this was the concept. And what is the brute force way of solving this problem? You are given a binary representation. What will you do? You will take first 1, which is 00001, and check this particular bit. As I told you before, you do this AND operation for these 2 and check whether the result is 0 or not. If the result is not 0, this indicates that this bit is set. So we'll increment the count. So this bit is set. We'll get a 1 here and all others are zeros. So we found the set bit here. And what we'll do next is we'll left shift this 1. So then what it becomes, we are going to check this bit 00010. This one gets shifted to left. So now if you do an AND operation here, you will know whether this bit is set or not. Everything else here are zeros, so naturally they will be 0, and here the bit is 0. So if you do an AND operation, you will get 0. The result is 0, which indicates that this bit is not set. So you will not increment the count and you will go towards the next bit. 10101 00100. Now notice that you have performed the left shift operation on this. Now you'll check these all become 0. This particular bit is set, so you'll get the result as 1. Now the result is not equal to 0, which means this bit is set. You will increment the count. So you go on doing this process until the end. Then you find the number of bits consequently. This was the approach. This was the brute force. And how much will be the time complexity of this approach? You are basically traversing all the bits, right? And now what will be the time complexity of this approach? Generally, our integers are stored in 32 bits. So you have 32 positions in the binary representation, and you have to check each and every position. So the time complexity becomes O of 32. If the integers had been represented in 64-bit or long, then it will become O of 64. So in this case, you are checking every particular bit. But I have got a better way, whose time complexity is big of set bits. Now let's discuss that approach. Let's take a binary representation 1 0 1 1 0 0 1. So there is a property which is called n is equal to n and n minus 1. If you do this operation on any integer, then the last set bit will become 0. If you do this operation on any number, then the last set bit will become 0. Let's take an example. Let's take 6. 6 binary representation is 1 1 0, and 6 minus 1, which is 5, its binary representation is 1 0 1. If you do an AND operation here, then what will be the result? 0 0 1. As you can see, the last set bit in 6 has become 0 in the result. Alright. So every time you perform this operation, one set bit will be gone. So how many times would you perform that operation? You will perform that operation unless the n becomes 0. Alright. When all the set bits are exhausted, you will stop. So the time complexity of this is number of set bits. This is better compared to the previous approach, in which we had to go through all the bits. But in this approach, we just are eliminating each one a single time. So until we get exhausted of all ones, we'll repeat the process. We'll do this operation. So I hope you got the point. Let's look at the code. Here is the code. We are given an integer a, and I'm running a loop until a becomes 0. I am performing the operation as stated before. a is equal to a and a minus 1, and I'm incrementing the count. Each time this operation is executed, one set bit is lost. So how many times will this loop be executed? It will be executed number of set bits times. So this was the code. I hope you liked the video. Thank you very much.